Welcome to Unit 2. Unit 2 focuses on everything linear functions, arithmetic sequences and series, systems of equations, and the whole lot. This is going to be a long unit, so sit back, buckle in, and hang tight. We're going to start with some vocab for this unit.
So the vocab is going to be very important for you to understand and put into your wonderful toolbox is what I call it. So linear function is a function with a constant rate of change, written as function or f parentheses x equals mx plus b.
And we're going to talk about f of x as we pronounce with the f parentheses x being our function this unit. That will be something that is relatively new to you.
And slope. Slope is the constant rate of change for a linear function. The ratio of the change in function to the change in x, or rise over run.
So rise over run is going to be the big piece, because remember, you got to get rise over run. You're thinking when you graph, it's run before rise, because you got to get in the elevator before you can ride it. But rise over run because you're going to go that vertical change over horizontal change.
And x-intercept, the x-coordinate of the ordered pair at which the line crosses the x-axis.
So this is going to be in the form of x, 0.
And then we have the y-intercept, the y-coordinate of the ordered pair at which the line crosses the y-axis.
So likewise, this one is going to be opposite. It's going to be 0, y, if you're thinking in terms of an ordered pair. One thing I do want to point out is that this is what it looks like. Remember, you graph an x-intercept on the x-axis, a y-intercept on the y-axis, and not vice versa.
So then we're going to use all of the information in the terms that we just used in our slope-intercept form, which is y equals mx plus b, where m is the slope and b is the y-intercept.
That's going to be huge because we're going to use that and see it so much over the course of this next unit. So what I want to do now is get into some examples. We first need to identify if the function is linear or not. For the purposes of this unit, everything's going to be a function. It's just a matter of whether it is linear or not. We'll get into how you tell whether things are functions or not in upcoming units. If you remember, when we talk about linear has a constant slope or a constant m. So we need to have a constant rate of change or constant slope, which means that as y changes, so y from here is plus 8, here is plus 8, and here is plus 8. That's constant. It doesn't always have to be constant as long as it matches with the other one. Here we go plus 3, here is plus 3, and here is plus 3. That means if I take all of my fractions, 9 over 2, 17 over 5, 25 over 8, 11 over 33, or sorry, 33 over 11, we won't necessarily have similar ratio there, but the change is. So that means that our m, or our rate of change, is 8 over 3. So yes, this is linear. So if it is linear, you should be able to give me that rate of change. Now on the other hand, when we look at b here, x has changed. This is plus 6, plus 6, plus 6, and because that's the same, then that means that these should be all the same. But this is plus 3, plus 6, plus 9. Now, while that increases at the same rate, we have a rate of change of 3 over 6, 6 over 6, and 9 over 6 if I'm looking at my numbers here. And because these are not equal to each other, this is not linear. Okay, the next piece is going to be, can we graph an equation when you have our point and the slope? You always start with the point. So we start there and we say 4, -5. That means I'm going to go to the right 4, 1, 2, 3, 4, and down 1, 2, 3, 4, 5. And then from there, we use our slope of 2. Remember, we got our rise over our run, but unfortunately, we just have a 2. So we have to turn it into a fraction, which is 2 over 1. So from this point, we go up 2 over 1, up 2 over 1, up 2 over 1. And you only need at least 3 points. I've now got 4, So I'm going to draw my line in. Make sure you put arrowheads on the ends of your lines. I am going to be picky about that because you are graphing a line. So then the next part is going to be given an equation of a line. You're going to find the x and y intercepts and then graph the line. So I want you to take a minute, think about what the definitions of x and y intercepts mean, and explain to me how you're going to find those x and y intercepts. Now that you've had that opportunity, when you do these, please make sure that you label which one's which, because I want to be able to see that you understand which one's which. So when I do my x-intercept, I know x-intercept means I want the number that x is when y is 0. So I'm going to take negative 4x plus 5 times 0 equal to 10. 5 times 0 is 0, so that's crossed off. So you have negative 4x equals 10. Divide by negative 4, and I get x equals negative 2.5. I do not want it left as just negative 2.5. I want it written as an ordered pair. So it would be negative 2.5, comma 0. Likewise, y-intercept, that's what the value is for y when x is 0. So now we've got negative 4 times 0 plus 5y equals 10. Well, this cancels because negative 4 times 0 is 0. So we have 5y equal to 10. Divide by 5, and it is not y equals 5, it is y equals 2. So now I need to write my ordered pair as 0, 2. Now to graph it, you graph your two y-intercepts. I'm going to go the route of this is 1, this is 2, every other line, just so I can make sure that I graph this as accurately as possible. So I'm going to graph negative 2.5, 0, and I'm going to graph 0, 2, and then I can just connect my dots. You typically need 3 points to make a line. When we're graphing using intercepts, I will allow you to only use 2 points. The final piece today is vertical and horizontal lines. If it is x equals a, that means it crosses the x-axis at a, and it'll be a vertical line. If it is y equals b, it crosses the y-axis at that b value, and it's a horizontal line. So knowing that, we look at x equals negative 4. It says x is always negative 4. So that means I graph at negative 4. And no matter what I put in, there is no y to put in, so that's why I have a vertical line, because there is no slope. So I draw my vertical line, and in these, I will allow you to only have to draw the y-intercept for your 1 point. Y equals 7. This is saying no matter what x is, y is always going to be 7. So it's going to cross the y-axis at 1, 2, 3, 4, 5, 6, 7. And it's going to be a horizontal line, because if we think in terms of y equals mx plus b, what's missing from this is the mx, which means that m has to be 0. This is a flat line. If you remember back to Algebra 1, you might have seen Slope Dude. Slope Dude would tell you this is 0 fun because he has to work really hard while he's skiing. And if you haven't seen Slope Dude, don't worry, we'll watch it in class. What I need you to do right now is you got some U-try problems. I want you to give these two a shot. The first two, I gave you tables. I want you to tell me, are they a function that's linear or nonlinear? And be able to explain why when we come to class. The third one is, I give you a point and a slope, and I want you to graph it. And finally, I'm not going to ask you to graph it, but I want you to find the intercepts for the equation 6x minus 2y equals negative 24. And as always, bring your questions with you to class.